All right, hey Tay, we are starting chapter 8. We are not starting 8.1 notes yet. We're going to do this example of hypothesis testing as like an intro into like, this is what the chapter is about, okay? So here's the deal. I think I mentioned this like at the beginning of the school year, and I said that like, let's say I work for a pharmaceutical company, okay? And we have a blood pressure medication, okay? A blood pressure medication, people like, that are a little bit older than you, like you probably don't have to worry about this.
My mom.
But people have high blood pressure. Some people
and
do, okay? And so that can be bad because that leads to heart disease and like strokes, and it can have a lot of underlying health conditions for people who have high blood pressure. Okay?
I have high
So
cholesterol.
people have to take blood pressure medications, right? Okay, so let's say a person with high blood pressure, we'll give them a really high blood pressure. We'll give them like 180 over, let's say their blood pressure is 180 over, you guys have gotta listen.
No, 54.
180 over 95. Okay, that's pretty high. Anything like 140 over 90 is considered high and above, okay? So let's say this person has a 180 over 95. Great. If the cutoff mark for what's considered to be high is 140 over 90, they are in the high risk range for high blood pressure. So we're going to put them on a medication, okay? And so there are different blood pressure medications out there that exist because every medication has a side effect, and we want to try to find the medicine that is best for them. Maybe some medicines make them nauseous and others don't, right? So if 140 over 90 is deemed like bad blood pressure, we want to give them a blood pressure medication, all right? So let's say I come up with this new blood pressure medicine, all right? And here's what's going to happen. It is taking this 180 over 95, typically that's the range that this person is in, and it drops their blood pressure down to like 175 over 90. Is the blood pressure medication effective?
No.
It's dropping it, it's reducing it, right? 175 over 90 was less than it was to start with, but are they like better now?
No.
No. So even though my medication is effective, it's the pressure of your heart when it's beating and the pressure of your heart when it's at rest.
Blood pressure is the one thing I cannot remember.
They like go by like the sound of your pulse. It's a process. Anyway, so it is reducing it. 175 over 90 is less than it was before, but is it like helping enough? Okay? Like that's what we have to ask. Is it good enough? That's what the whole process is about. Is it good enough? Question mark. Okay? That's all that we're asking on hypothesis testing. Is whatever number I give to you, is that good enough, or is it close enough? Or is it far enough away from what it was originally to be whatever result that we are wanting, okay? So here we go. Let's go through the M&M example, all right? We're backing off of something that's a little bit more serious to like an M&M example. So I get that like we probably wouldn't care about colors of M&Ms like colors of Skittles, but think about this in like the pharmaceutical sense, okay? So we have M&M weights in Appendix B, whatever. They said that they have tested 100 M&Ms. Okay, I'm going to list that off to the side because they're giving me information now. What would 100 represent? N. There you go. N is 100. I'm pulling this stuff out. 27% of them are blue.
P.
That is P hat. That is like data from what like our sample says. Okay, our sample is saying 27% are blue. Okay, that is P hat. And I'm going to put blue. Put blue here somewhere so we know what color we're talking about. Okay, the Mars Candy Company. Let's talk about their claim. Their claim is that the percentage of blue M&Ms is equal to 24%. Okay, so they're claiming that the population, which is P, not P hat, the population of blue M&Ms is P, is equal to 0.24. Now that's not what we got. We got 0.27. But is that close enough to 0.24 to say that like, okay, Mars Candy Company will say 24% is about okay, right? That's what we have to decide, okay? Now here's the deal. Let's say you love blue M&Ms because they like taste better than all other M&Ms, right? Okay, sure. Okay? And the Mars Candy Company claims that 24% of all M&Ms are blue. And you got 22%. Let's say you got 22% blue M&Ms. Is that enough to make you mad?
No.
Okay, what if you got 20% blue M&Ms?
Yeah, 100%.
Like, where's the threshold at that if you have like a certain like percentage below, like when are you gonna start to get upset? Like if you have 3% blue M&Ms, is that gonna be enough to make you mad?
They don't last.
You gotta listen.
Still fire.
Where's your threshold? Cray, where's your threshold? If they claim 24% are blue and you really love blue, how low would that have to be in order for you to be like, no, this is crap?
20.
20%? Anything below 20% is Cray's threshold? Okay, that's what we have to decide. Like, when is too low to say, no, Mars Candy Company, you are not right, right? Like that 24% is no longer valid. You need to revise your thing that says 24%. Yes. Mars owns like a ton of,
Yeah, like all chocolate bars.
yeah.
Doesn't Hershey own like Reese's and all
I
that?
think Mars owns Hershey.
Oh, they do?
Yeah, like Mars owns everything.
Whoever the Mars guy is,
Mars
they
has
get
bought a
baked.
lot. Anyway, okay, so that's what they're claiming. All right, let's go
One dude
through.
had to start it.
Okay, more information. Listen, we gotta go through the paragraph again. Okay, use a 0.05 significance level. We're going back to this guy. This is my fish. That's my significance level. Okay, write him down. A significance level of 0.05 to test the claim. That we are at 24% blue. Should the Mars Candy Company take action?
No.
So we got 27% blue. They are claiming 24% blue. So do they need to either go back in the textbooks and say it's not 24%, it's closer to 27%? Do they need to change something in their factory that's actually like making less
They need to add
blue?
another
Do they
color.
need to they need to add another color? Do they need to do something to change that number? Because we didn't get the same results that they did, right?
We need a white M&M.
All right.
Not in the package,
Steps.
dude.
Here you go. This is where you gotta listen. Steps 1, 2, 3. Use the original claim to create a null hypothesis, which is denoted H0. This is H null.
Oh.
H0 is the null hypothesis. We have got to identify the null hypothesis and the alternative hypothesis. They call it H1. Sometimes they will call it HA. Okay? So H1 or HA, I don't care what you call it, but that means the alternative hypothesis. So we always start with it being equal. We're gonna say, okay, Mars Candy Company, we'll say that you're right, and we'll say that your purple or your blue M&Ms are in fact 24%. We'll say that you are right, and we'll say that you are 24% blue. Okay? If that's wrong, what would the alternative hypothesis be?
27.
Huh?
If that's not right, if it's not 24%, it's not 24%. So the alternative is that it's not 24%. Probably that it's higher than 24% because we got 27. But we'll just say equal to, not equal to. Got it? That's my null hypothesis, alternative hypothesis, okay? When you're doing these hypotheses, you will always start with equal. Your null hypothesis will always be that they are equal, okay? You got to do it that way. Always that it's equal to whatever they're claiming, okay? Equal to whatever they're claiming. Select the significance level of alpha, okay? This is where this gets a little bit confusing.
Can I close the tail on alpha?
What?
I don't
No.
know what to do. That makes a little
Like to
bit-
make a fish? No.
Yep.
All right, here's how this works. Draw a bell curve under step 4. Here's what I'm gonna do. Draw a bell curve. Make it like as good as you can. Emma, you're gonna wanna listen to this. Okay? Emma, you gotta listen.
I'm listening.
Okay, I'm gonna make 2 little cutoff marks and we're gonna shade them black. Okay? Do this real quick.
That's orange.
Okay? Shade them black. Orange, whatever color.
Oh,
Okay? Okay, take your bell curve and we're gonna shade them black. All right, so here's what we are testing. This is the overall view of it, okay? 24%, what they're claiming. P equals 0.24. That lives in the middle because that's what they're claiming, all right? Now, if we are over here, if we test our value and our value is over here or over here, we're gonna say that that lives far enough away from 24% that they can no longer claim that it's actually 24%. They need to revise their system, right? So we have to decide, okay, we got 27%, but does 27% live over here? Or does 27% live over here? Is 27 close enough to 24 to say that, okay, we'll buy your 24%. Even though we got a little bit higher, it's not high enough to say that you need to go back through and redo all your advertising, okay? So like we have to decide, where does our 27% live? Is it over here in the shaded region where it's far enough away to say that they're wrong now? Or is it close enough to 24 to be like, okay, we got 27%, but if we ran this test again, maybe we would get 24% or something, right? Like, are you wrong or are you not wrong, right? Like, where do we fall? Do we fall over here? Do we fall over there? And that's what we're doing in this test, okay? And it has to do with the significance level. So, like, how significant we want to be. We have a fish of 0.05, so we're saying a significance level of 5%. It's kind of like saying 95% confident, okay?
Track that.
A fish level of 0.05 is kind of like saying 95% confident, okay? Now, that fish level will change just a little bit when we start to do the actual notes for 8.1 because we'll be looking at not equal to, but we're looking at greater than and less than, okay? So just go with that for now. 95% confident, okay? Now, normally, 95% confident tells us our Z, and that's true in this case, right?
1.96.
Okay? If we look up on the chart, that 95% confident is 1.96. Perfect. Okay, this is like what we're used to seeing. 1.96 in the little box in the corner of the positive chart. 1.96, that tells me what my fish level or 95% confident is. Are we good to go? Okay, now, before we start the process, we have to check step number 5, which is like, I usually overlook step number 5 after we do it the first couple times because, you know, whatever, okay? It has to check these two boxes, okay? It has to check these two boxes. So in the first couple examples, we do need to check these boxes. We have to check to see if n times p is greater than 5. What was n?
100.
100. What was p?
0.27.
0.24. P, not p hat.
Whatever.
Okay? It's 0.24.
Yeah.
100 times 0.24 is 24. Is that greater than or equal to 5?
Mm-hmm.
Yes. If it's not, we can't do this process because like we have an outlier and we have like so few number of M&Ms that this doesn't work for, okay? If P is 0.24, what's Q?
0.76.
0.76. If I take 100 times 0.76, does that end up being
Yes.
more than 5?
Yes.
Yes. We have to check those boxes off because if one of those things takes place, we have like too small of a P and we can't do this process, right? Okay? Now, we check that off for the first couple problems, and then after this, like going into chapter 8, they're probably not going to give you one that you can't do. So you can probably overlook this step, but that's one thing that we need to, like, one hurdle that we need to go over. Okay? Got it? All right. This is the actual testing part. Are you ready? This is the actual testing part. There are two different methods of doing this. There's the p-value method and there's the critical value method. I like the critical value method better. But about half of the people like the p-value method better, and I'll show you how this works, okay? First thing we need to do is find the test statistic. Test statistic. Here's the formula for finding a test statistic for p. We will eventually do for mean, which is mu and x bar. Then we will do also for standard deviation, kind of like we did in chapter 7. Proportions first, then mean, then standard deviation, okay? This is the test statistic for P. This is Z, is what we're comparing. We're going to end up comparing this Z to the Z that we got 1.96 up here. We're going to end up comparing those two. Do you see how that works? That's what we're going to end up doing, okay? Here we go. So, I'm going to write these values in here. P hat was what? 0.27. That's the value that we got. Minus, what's P? 0.24 over, now I take the square root of all that stuff, right? Everything on the bottom is underneath of the square root. P is 0.24. Q, not Q hat, Q
0.76.
is 0.76, okay? All over N was 100. All right, so everything in the bottom, like if you do the bottom, your parentheses need to go there, and you can put times and you can put divide here if you like have a dumb calculator and you want to do it that way, right? Okay, so on the top, this is just going to be 0.03, but on the bottom, whatever that number is, type that in somebody and get me what Z is.
0.702.
0.702?
Yep.
Okay. 0.702. Got it. Okay. All right. I'm going to show you critical value method because I think it's easier. I totally think critical value method
What
is
do we
easier.
do with that?
Okay,
number?
here's what we do with that number. So this is the Z that we got. This is our Z, or our test statistic, our Z that we got, okay? All right, I'm gonna draw a bell curve. We have to have a bell curve for each one of these. Here's the critical value method, okay? 0 lives here, right? 0 lives in the middle, and that's like what P is, 0.24. So if we change and we do the z-score of 0.24, it is 0. 0 lives in the middle. That's where 0.24 lives, okay? All right, we have these two cutoff marks, and we said anything over here is going to be like too far away from 0.24 to say that like they're wrong, right? This cutoff mark for z is 1.96 from our fish value above, and this cutoff mark is negative 1.96, right? Like that's how this bell curve works, right? 1.96, negative 1.96, which means that our z value that we just got, if it is above 1.96 or below negative 1.96,
It doesn't work.
it's too far away from 0.24, right? Does that make sense? Okay. So where does our z live?
Inside.
Inside. He lives here. 0.7. What was it? 0.706.
Yep. Oh, 2.
702. Okay. 0.702 is inside of the 1.96 range. That's the cutoff right here. Okay. So are they right by saying that it's equal to 0.24?
Yep.
Yeah, we got 27%, but what they're saying is that, like, okay, 27% is not far enough away from 24% for us to be angry, right? Does that make sense?
Yeah.
If we were in this range, we could maybe sue, right?
Yeah.
Like, why would we sue for blue M&Ms? But if this is a pharmaceutical scenario and they're claiming something, you better believe there's going to be people suing. There's probably going to be people suing over blue M&Ms too, but those people are idiots, right? But if this is a pharmaceutical example and they're claiming something and we got results that are very, very different,
So that I can win.
we could sue, right?
Get hit by
Okay.
a car. By a rich person.
Work
Jump
for
off
the
of a
railroad.
building and
Work
swim.
for the railroad and get hit by a train.
Okay, so here's the conclusion.
No, don't die. Just break your leg lip or something.
Yeah, you could die, and then you
And
could
then I
sue
could
them
sue
because it
Red
didn't give
Bull.
you wings.
Oh my.
Yes.
Okay.
False
Okay.
advertisement.
Yeah.
It is. I never grew wings.
Or if you can't taste the rainbow with Skittles. So,
But what does a rainbow taste like? Because a
Exactly.
rainbow's just
Okay,
water.
so I'm gonna say that this is in the middle region. Yeah?
oh, that's valid.
Good
So,
point.
In the
water
middle
does not
region.
taste.
Agreed? 0.702, the number that
You
we
sue 'em
got
and
was
tell
in
me
the
how it
middle
goes.
region.
I tasted something,
Okay.
so actually this isn't rainbow.
Alright, let's go over.
I actually found the
Nobody's
end
ever
and tried it.
tasted a rainbow or
Okay.
like walked through it.
We're gonna have to try
And
it.
know
Well,
that
actually,
it's water.
you have.
It's actually light.
Actually,
Actually,
it's
it's
Alright.
gone full circle.
Here we go.
It's literally water.
Let's go over and talk about the p-value method. Here we go. Some people like this p-value method better.
It's light. Isn't it?
Listen to this.
It's
Yeah,
light.
it's just water.
It's
Some
light
people
hitting
like
water.
the p-value method better. You gotta listen.
Wild. So is the rainbow water or light?
Some people like the p-value method better. Let's talk about this one, okay? Shade your two tails. These are called tails, by the way. They call them tails. Shade your two tails, okay? Now, the p-value method. P stands for percent. The percent value method. So what I'm going to do is rather than this bell curve, rather than it being 0 in the middle and then our z-scores are negative here and positive here, right? Like that's how the critical value method went. This is going to be like a number line where 0% lives here and 100% lives
I
here.
don't like that.
And 50% lives here in the middle. Okay, it's like a number line. 0%, 100%, 50% is in the middle. Okay, we said 95% or 5% was my fish. Okay, now here's the deal. 5% was my fish, but
So
2.5% is going to live here, and 2.5% is going to live here in the like shaded range, right? That makes a total of 5% for my fish, right? So if I'm looking at percentages, anything lower than 2.5% is going to be like unacceptable. Anything higher than 97.5% is going to be deemed unacceptable. Okay? All right.
Yeah.
So do we see how this number line works? Okay? Rather than 0 being in the middle and then positive, negative z-scores, now we have percentages, 0 to 100%. Okay? Now, here's what we do. The last thing we do is we look up our z-value, which is 0.702. Now, when you're looking up stuff on the chart, we only do 2 decimal places, so we're going to look up 0.70. On your chart, what I want you to do is grab the positive chart, the one that says positive at the top. Grab that chart, get it out. Take out your positive chart. Positive chart, okay? Go and look up for Z. Look up 0.7 and 0.00, like this first column in 0.7, and find what that percentage is.
0.758.
I'm looking, Kelsey.
0.758.
What?
Shouldn't it be 4 decimal places?
It's
Zero.
0.7580 is what you got, right? Okay?
Yep.
So a z-score of 0.70 corresponds to 0.7580, which is 75.8%. Agreed? If this is where 0 lives and this is where 100 lives, where does 75.8% live?
Good region.
Right here, in the same spot as this one did, but we're comparing different numbers, right?
Mhm.
We're just doing it a different way. So 75.8% lives here, yeah?
Yeah.
Like in the good region. So we are saying that they are correct by claiming 24%, right?
That seems
What?
way harder.
Okay.
No, I kinda like it a little
You
bit.
see, we're usually split about half and half. Some people like the p-value, some people like critical value. I don't know. Whatever you want to do. Okay?
I think
Now, you're gonna no matter what have to use this chart at some point, and here's where the chart lies. Okay?
Yeah.
If you do the critical value method, you have to look up the chart at the beginning to figure out where this number is. Okay? If you do the p-value method, you have to look up our z that we got for our calculation. Okay? So it just depends on how you're going to use the chart. Okay? To which method you use. Does that make sense? Okay?
But those can be used on every single problem.
But you can do the p-value method or the critical value method for any of these problems.
On the test, are you gonna say do the critical or do the?
On the test, I say do whatever you want.
Oh, okay.
Now, we get to some places where, like when we do mean, you have to do the critical value method because the p-value method is icky. Because some p's are not, like, some p-values are not, like, there for mean. But we'll get to that, okay? So, on the test, you get to do whatever method you want, okay? Now, here's the deal.
Oh my god.
Here's the deal. We have to talk about what we're going to do with this guy versus this guy. I'm going to call him H naught and HA. H naught was that it was equal to 0.24, and HA was that it was not equal to 0.24, okay?
I'm so proud of you.
This is what we have, okay? All right, don't. We got 2 more things left and then we're done,
Really that big of a
okay? Shh, yes.
Yes.
I have like ADHD or something, and like, no, I have a
So do
sensory
I.
sensory disorder.
I should take Adderall.
Like overstimulation. Yeah, 100%. Autism, there you go. Okay,
Whoa.
great, I have that.
I think we need to count
Anyway.
how many words you say in a day.
Sure.
We all
Sure.
have bigotism.
All right, are you ready? Step 7, step 8. We've already done all the work. We just have to write out our conclusion. Ready? Here's the deal. Okay, we said I'm going to end up circling one of these and I'm going to end up crossing out one of these. Okay? Which one is like correct, technically,
The second.
according to our results?
Oh.
Oh,
A.
not.
Huh?
The first one.
No. the
Did
second
we
one.
say it was close enough to
Yes.
24%?
Oh,
Yeah.
Yeah, so we're going to circle this one and we're going to say this one's not correct, right?
Oh. Well, technically, that first one is not right because it's not equal to 0.24.
It's not equal to 0.24, but it's close enough to 0.24 to say
Yeah,
that
you
like
said
their
you
results are
said
correct.
which one's
Now,
correct.
here's the
Out
deal.
in the parking lot.
You have to be very, very, very particular about how you word this. Ready?
This pencil
Okay.
finally
This
does
is the tricky part. Ready? And they're gonna ask you a question about this. Okay? You're either going
I
to
just haven't used it.
do
I
2
had
options.
it.
Option 1
This is like it.
or option 2.
Should I throw it?
Okay?
Oh my gosh, there's
We can either reject H naught. Why did I spell that right? Reject H naught. Okay? That's option 1. We're either going to reject H naught
Or accept
or
H
we're
naught.
not going to accept H naught. We are never going to accept H naught.
Okay.
All we're going to do is we are going to fail to reject H naught. Okay? There's a difference between accept and fail to reject. Okay?
It's like rap.
I'm going to say accept kind of.
Basketball game.
Well, I finally feel like I'm not being.
Okay?
He said they'd be
I finally feel like I'm recognized.
All right, so here's the deal.
Being recognized.
Listen to this real quick. We have like one more thing to do after this and then we're done. Okay? We have 2 options. We're either going to reject H naught. We did not in this case, so we're not doing this option. Okay? That does not necessarily mean that we are accepting that they are correct, right? Okay? We
On
said
God.
0.24 was correct in this case, right? Does that mean if I run this test again, they're going to be right every time?
No.
No, that's why we don't accept H naught. We only fail to reject it because the information that I was given, the 27%, was not far enough away from 24% to say that they're wrong. Now, if I run the test again and it ends up being 30% that I'm comparing to 24%, we might end up rejecting in that case. That's why we don't accept it as truth. We only say, you're right for right now, right? Like, you're okay for right now. 24% is all right. But you better watch yourself because if you end up getting closer to like 30 or 35%, you're probably gonna be not correct anymore. Does that make sense? So we say fail to reject rather than accept, okay? We never use the words accept. We never accept it as 100% truth. We only fail to reject it given this scenario, right? Okay, last thing. Fail to reject is kind of like accept, okay? So step 8, restate the decision using simple and non-technical terms, okay? We're gonna say the claim for right now is correct. They claimed 24%. The claim is correct. This is like your explain part, okay? The claim is correct, okay? We are failing to reject H naught. So claim is correct. We are saying Mars has approximately 24% blue M&Ms. That's what we are saying. We are supporting what their claim was, okay? Even though we got 27%, that is not far enough away from 24% to say that they're wrong, right?
Alright.
Okay? Good? Makes sense?
Yeah.
Okay, there you go. That's the whole process, the whole 8 steps.
Tyler
Woo!
Huntley made me promise.